Alright, I have now fully assembled the blades into the hub. There's no play on any of the three blades, so I'm satisfied with that. Check it out, I've got three blades attached. Alright, now here is a 5/8 inch propeller adapter for a 5mm shaft. I'm just going to slip this on, give it a twist, take a look at it. Alright, so I've got a little bit of up and down here. You can see that. So there's still a little bit of adjusting for me to do. I'll identify the high or low blade and make adjustments until I can get that to flatten out. Okay, so the next assembly feature is to install the dome. Now it won't fit presently because there's a wee bit of stringing going across the slots. See if I can get that into focus. Okay, camera's going to fight me on this one. Okay, so there's 4 slots. There we go. I had it there for a second. Alright, so in any case, I need to clean these slots. For that, I'll use the extra pointy carbide bit. Get in there and clean those up. And I'll use not a flat file like this one, but a round file. Okay. I have a long round file like this. I also have a shorter one, which the handle end broke. So I filed down and smoothed down that end, and I will use that to go around the inside and just make sure that there's no stringing that's in the way. Take down any high points. I'll do that very carefully because it's a lot easier to take the flat file and work on the surface of the dome than it is to work on the inside of the hub. But I definitely want to make sure that that wall in there is nice and smooth. I'm ready to accept this once I clean off the flash off the base here. So I'm going to go ahead and take my flat file, very carefully go all the way around the dome base. Including the bottom of these tabs. Okay, let's do a preliminary fit. And currently we're not fitting. So, let me get that Dremel ready. Alright, I've got my needly pointy carbide bit with the straight edge on it. There's no curve on that edge. I'm going to go ahead and clean up those slots. And this one has a pretty big string in it. All right. Now I'm going to take my flat file here. I've got a flat file with a tapered tip. I'm going to go in sideways here. See if I can clean that up. All right, let's see if I can get this dome to seat. All right, there it goes. We're actually fitting down into the slots a little bit. You don't want to force it down and get it stuck. I'm going around and around here because each time I slide this down, it helps clear it up a little bit more. All right, so what I'm going to do now is I'm going to take material off this wider flat section of the dome here. Now, I don't need to go all the way across, so I'm just going to put my thumb in the way there. Take some material off of each one. Don't want to take too much. You want a good press fit. All right, that went down quite a ways. That was good. Okay, that's the fourth one. I've turned it a quarter turn each time I fitted it. And I've managed to extract this without breaking it. Alright, so let me trim off a little bit more. And trim off the sides. And also, I'm going to put just a tiny, barely perceptible bevel onto that corner. Alright, let's try fitting it again. You notice I only took 2 swipes per side. Okay. Still not going all the way down. Okay, it's fitting better. And like I said, you want it to be snug. You want to have it what I call a slip grip. You don't want it to be loose. You don't want it to come off. It still needs some work. So this time I'm going to take my flat file and I'm going to go through the inside again. like this. That one feels pretty smooth. Okay, then test fit again. Basically what we're doing is we're rinsing and repeating. Okay, that looks pretty good now. Okay, that fits down pretty nicely. The top of this rectangular section is sticking out. It's a little bit oversized. To get it truly scale, you probably want it seated a little bit further. But I'm going to sand this base down a little bit. That's part of the fitting process also. All right. So I'm going to work on truing up these blades so that they all the points hit at the same spot as it goes around. So if it's going around, you want these points, you don't want them here or here, you want them hitting all evenly in the plane. So when you spin it from the side, they're tracking straight. So that means finding which one of these is out of alignment and working on it until it aligns properly. So I'm going to do that and sand down the base here, and I'll show you the finished product. Okay, while I was aligning the blades, the number 3 blade, this one, was leaning forward a bit too much. So in order to bring it back, I needed to sand down the upper part of the blade at the rear of the holder and the lower part of the holder at the front edge right here to change the angle slightly so that the blade would lean back. Now it turns out I took it too far. Now there's a wobble in the blade. So in order to fix that, what I'm going to do is lay a bead of CA glue along this top edge right here so that it fills in the space and forces this blade to go down a bit like that. So, making sure that I'm doing the top edge. I'm going to put 1 drop of CA glue at the front right there. And then I'm going to take a toothpick and I'm going to spread this into an even bead along the top only. Then I'll tilt it down, kind of like this, and just give it a tiny little spritz. Okay, before I do that, before I spray accelerator, I'm going to make sure that the CA is not bunched up on one side or the other. Okay, there we go. And I'm going to let that sit for a bit. Let that bead harden. And then reassemble the propeller. Alright, it turns out that after putting that bead on, I still have too much wobble in this blade. So, what I'm going to do is disassemble and then lay in a bead along the bottom half of that blade. I'm going to thicken up that rear blade holder, the larger area, until the slop disappears. Alright, take a look at that. See, I've laid an even line on the top and the bottom of the back side of the blade holder, so I'm trying to thicken this section up until there's no more room in this slot, so that it can't wiggle. Okay, there's the number 1 blade. It's set. Number 2 blade is set. Number 3 blade now does not wiggle. That's set. Alright, there's still a little bit of drift in the tip, but you know what? I'm not going to worry about that too much. These are going to be field propellers. They're going to be on use on my utility aircraft, and so they're going to take a beating anyway. If I was going to make this into a totally scale airplane, I would take a lot more time to refine the angle of the blades, but that blade tracking is okay for me. Alright, now we fit the hub on and do the same thing. And the hub seems to be tracking fairly true. Let me see if I can get a better track. Switch that over by 90 degrees. Give it a spin. That seems to be a little bit more wobbly. Nah. Next one. Oh, that looks pretty good. All right. So now I'm going to take my Sharpie pen here. I like this alignment, so I'm going to make a black mark right there on the dome and a corresponding black mark on the hub, so I know how to align that so that it spins as true as possible. All right, there we go. I have here a propeller that is ready to go on an airplane and fly. And it looks like a Hamilton Standard Hydromatic Propeller. I like the scale look of it. Now, with any scale model, you can always refine it. It's a little rough. I can definitely do some cosmetic cleanup work on it. But for all intents and purposes, this is now a flying propeller. And that includes the instructions on how to assemble your 3D printed Hamilton Standard propeller.